guys, so 6.3, we are determining what we call the slope of a line. So I need to give you the definition of slope first. Slope is the rate of change of a line, meaning it indicates how steep the line is. So slope, another word for slope could be steepness. I'm working on the handwriting thing. Okay, another word for slope is steepness. Steepness is another word for slope. There. Okay. Now, there's a couple things that we need to know about slope. The variable that we associate with slope is not S, it's M. So anytime you see the letter M, it means slope. Okay? The reason why we don't use S is because in science, S means speed, and so they don't want to confuse the two. So we use M for slope. This should be familiar to you. Slope is the vertical change, so going up and down, over the horizontal change, going left to right. Okay? So slope is vertical change over horizontal change, or another way that we write that is rise over run. That should be the familiar part, right? Okay? So slope is the steepness of a line. The variable for slope is M. We call it vertical change over horizontal change, or rise over run. Vertical change means the Y's, or rise means the Y's. Run means the X's. So how do I find the slope from a graph? So what we're going to do first is we're going to be looking at a graph and counting the slope from the graph. So what you're going to do is you're first going to pick 2 points, any 2 points on the graph. Sometimes the graph will actually give you the numbers of the points, the coordinates. Sometimes you'll have to pick your own. So you would just pick them at the crosses where they cross the grid lines. Okay? So points are found at where they cross the grid lines. Where the line crosses the grid. Okay. So if the points aren't given to you, as in it doesn't tell you the actual numbers, you can find it by finding where the line crosses on the grid. After you pick your 2 points, you are going to count the number of units up or down from the first point to the second. If I am counting up, will my number be positive or negative? Positive. If I'm counting down, what would it be? Negative. Okay? So first you count the rise, up and down. After you count the rise, you want to count the number of units left to right, or the run from the first point to the second. Now, which direction would be positive, left or right? Right. So if I have to count to the left, that means my number is going to end up being negative. Good. So then we're going to take that and write it as a fraction, rise over run. Make sure that you simplify the fraction as much as possible. So let's take a look at example 1. I gave you 2 graphs, and all they want us to do is to find the slope of each of these lines. So remember, slope is what? Rise over run. So with slope, we first need to count rise, which is up and down or side to side? Up and down. So pick a point. So we're going to be finding the slope. It's a fraction. Do you want to pick the lower point or the higher point?
Higher point.
The higher one?
Yeah.
Okay, so let's start at the higher one then. It really doesn't matter which one. I typically start with the lower, but that's okay. Start with the higher one. How many spaces do I need to count down to get to the other point? 1, 2, 3. Now I'm going down, so is that positive or negative? Negative. So my rise is going to be negative 3. Rise is always on top.
And
Now my run, I'm going to go from where I left off and count how many places left to right I have to go. So how many do I have to go? 1, 2, 3, 4, 5. But since I'm going to the left, is that positive or negative? Also negative. So my run is negative 5. Is that my whole slope? Negative 3 over negative 5.
Yes.
Can I reduce that? What's a negative over a negative? Positive. So my slope is actually 3 over 5.
So you always want to try to make it.
You only want to have 1 or 0 negatives. If you have 2 negatives, you need to change it to positive. Juliana asked, what if I started at negative 2, 1 and went up 3 and right 5? You would get the exact same answer. So you can go either way. Okay? Like I said, typically I start at the lower one and then count towards the upper one, but it really doesn't matter. So what I want you all to do right now is try B by yourself. So find me the slope of B. You can start at either point. It does not matter. Okay, guys, how many of you started at the point negative 3, positive 2, the higher one? Okay, how many of you started at 3, 1, the lower one? Okay, I'm going to start at 3, 1 then. So we have to count rise or run first? Rise. So if I'm starting at 3, 1, how many places do I have to go? Up 1. So that's going to be positive 1. Then how many do I have to go? Left, 1, 2, 3, 4, 5, 6. So if I'm going left, is that positive or negative? Negative. So if I'm going left, it's going to be negative 6. So our slope would be 1 over negative 6. Another way that you could write this, if you went the opposite direction and started at the higher point, you could write it negative 1 over 6. Same thing. Or the way that I do it, I just put the negative on the outside. So I write it as negative 1 over 6. It's all the same thing because there's only one negative in there. So it doesn't matter where you put the negative. Okay?
So if it was on the top, you could put the negative?
You could put the negative on top. You could put the negative on bottom. You could put it on the outside. As long as there's one negative, you're totally good. Okay? Okay, so what if I want to find the slope, but they don't give me a graph to count? We have a formula for that. So to find the slope, you're going to be given 2 points, okay? So typically you're going to be given 2 points, but you know how points are always written x comma y and x comma y? If I have 2 points and I call them xy and xy, then that would get confusing, right? So what we do is we label them. We'll call the first one point 1. So that gives us x1 and y1. That's where we get the little ones from. Okay? So x1 and y1, because this one is point number 1.
So the reason why it's...
The reason why you have the little ones is to indicate which point it's coming from, point 1 or point 2.
So when you have little 2s, that's point 2?
Correct. So let's call the second one point 2, which means this is going to be x2, if my thingy will write, x2 and y2. So that's where the little ones and the little 2's come from. They're telling you which point you're using at that time. Okay? Since we have to count the rise first, y's go on top always. Run is on bottom, so the x's are on bottom. Right here, this part that says x1 minus x2 cannot equal 0. If I have x1 minus x2 in the denominator as 0, what happens?
It becomes nothing.
So let's say you're finding your slope and it all comes out to 4 over 0. Is that allowed?
No.
Are you allowed to have 0 in the denominator? No. So if you ever get 0 in the denominator, it is undefined. I write undef, okay? If you ever have 0 in the denominator, it's undefined. This might come up. Just a warning. Okay? something else that I want you all to notice is in the numerator, which point do I use first? Point 1 or point 2? Point 1. In the denominator, which point do I use first? Point 1. You have to use point 1 first each time in the numerator and the denominator in order to get the right answer.
So is it always going to be y over x?
Yes, y's are always over x. Okay? Okay, so now that you have the formula, how do I use the formula? First step, you are going to plug in the two y coordinates for y1 and y2. So y's are always on top. Okay? Step 2, you're going to plug in the two x coordinates. And remember, like I just told you, make sure that the coordinates are in the same order as in step 1. Meaning, you have to use point 1 first in the top, and then point 1 first on the bottom. Okay? They have to be in the same order. So then after you plug everything in, you are going to subtract, because our formula says you subtract, and simplify and reduce if you possibly can. Okay, so you need to simplify and reduce if possible. Since our formula is subtraction, you are always subtracting. Okay, y is on top, x is on bottom. Okay guys, so I want you to look at some special, we're looking at positive and negative slopes, so I want you to look at these right now. One way to check that we graph something correctly is to look at, see if the slope is positive or negative. Now, which direction do you read words? Left to right. So we read words or graphs in the same direction. We always read graphs from left to right. Okay, so when you are looking at a graph, look at this first one right here in the upper left-hand corner. We call this a positive slope because it goes upward when you're reading left to right. The way that I think about this is think about a little person walking on the line. If he's walking along the line, is he going uphill or downhill? Uphill. So uphill is a positive slope. Okay? So if the slope or if the line is slanting the other way, going downward from left to right, we call that negative slope. So which way is our little man walking if he is on this line? Downhill. Downhill would be negative slope. Okay? The reason why I point this out is because you should be able to look at what you get for slope. If it's a positive number, like our very first example that we counted, the slope was positive, the line should be going uphill like this. If you calculate slope and you get a negative number, the line should be going downwards. Like the second one. We also have two special cases of slope. The first one is if the slope comes out 0. So if a slope comes out 0, the line is horizontal, meaning if our little man is walking along the line, is he going uphill or downhill? Neither. He's just walking on flat ground, right? That's a 0 slope. 0 slope happens when you have 0 on top and a number on bottom. Okay? So 0 on top and a number on bottom. That's allowed. It's okay. What about those undefined ones? What if you have a slope that has 0 in the denominator? It's undefined. And the line is a vertical line. And we know that this is not allowed because if my little man is walking on that line, what's going to happen to him? He's going to fall off. It's not allowed. So this is undefined slope, meaning that we have a number on top and 0 in the denominator, which we already know is not allowed, right? Okay, so those are your positive and negative slopes, horizontal or 0 slope, and undefined slope, which is vertical. So example 1, we want to find the slope running through these 2 points. My suggestion is that you pick one point to be point 1, you pick one to be point 2, and then you label them. So I usually typically pick just the first one as point 1. So if my first point is point 1, x1 is going to be 3, and 2 is going to be y1, right?
Confusing because if you put the comma with the 1, it looks like
Yeah, I know. You just have to remember it's a 1 and a 2. Okay, so what's going to be x2? 5. What's y2? 6. Okay, so I just label them so that I know which ones go where. And now we're going to use the slope formula. So slope, or M, equals what always goes on top? Y's. So we have 2. And to find the slope, we are always adding or subtracting? Subtracting. So 2 minus y2, which is?
Wait, why does y's go on top?
Because its slope is rise over run.
Oh.
So you would do, wait, how much is 6?
Because y2 is 6. So you're only using the y's.
Plugged it in.
You just plug it in. Right.
I thought you did some kind of
What goes on bottom then? Which one has to go first? 3 or 5? 3. So this is 3 minus 5. Slope is always subtraction, guys. Always. Y's are always on top. X's are always on bottom. Now, does this look like a completed slope? No, we actually have to do the math. What's 2 minus 6? Negative 4. What is 3 minus 5? Negative 2. And negative 4 over negative 2 gives me? Positive 2. So your slope is positive 2. Do I have to write the over 1 part? No. But it is there, right? Okay.
It didn't just disappear.
All right. Okay, so let's look at example 3 then. That's not bad, right?
It's not bad.
Look at example 3. What do you want x1 to be? What's going to be x1? Negative 1. What is, I'm going to throw you off, y2?
8.
Good job. So what's x2? 4. So that makes y1 3. Okay, so I labeled them for you. I want you to try this on your own. I'm going to be coming around looking for somebody's perfect work to show everybody. All right, this is a picture of Annabelle's work. Her example number 3 is right here on the bottom. So her point is negative 1, 3, and 4, 8. So on top she put 3 minus 8. Is that correct? Y's go on top. And negative 1 minus 4. The only thing here, Annabelle, that you need to make sure you do is make sure you put equal signs in between the two so that we're showing that they're equal. 3 minus 8 gave her negative 5. And negative 1 minus 4 gave her negative 5. And negative 5 over negative 5 reduces to positive 1. So her slope is 1. How many of you got positive 1 as your slope? Fabulous. Okay, so let's look at example 3 then. Okay, example 4. We have negative 2, negative 5, negative 3, negative 7. The reason why I want to do this one with you guys is because negatives can be tricky. So first let's label the points. Negative 2 is going to be x1. Negative 5 is y1. Negative 3 is x2. And negative 7 is y2. So if I am looking for slope, what goes on top, Tegan?
It would be negative 5 minus negative 7. You have to do parentheses.
Okay, why do you have to put parentheses around the negatives?
Because there's 2 negatives.
Correct. Yes, we will in just a second. Okay, and then what goes on the bottom, Tegan?
Negative 2 and negative 3.
Negative 2 minus
Minus.
negative 3. Good. So then Maddie says, wait, doesn't a minus and negative turn into positive?
Yeah.
It does. So this is actually
Addition.
negative 5 plus 7. So what does that give me?
12.
What's negative 5 plus 7? 2. And what is negative 2 plus 3? Positive 1. So my slope is 2 over 1 or just 2. Okay? Yes. So, example 5, just because we are starting to run out of time. My slope is going to be, what goes on top?
Y's.
Y's. So that's going to be what? 2 minus 2.
2 minus 2.
What goes on bottom?
X's and it'll be 5 minus
X's. So that's going to be 5 minus
7.
7. Okay, what's 2 minus 2, guys?
0.
0 over
Negative 2.
negative 2. So what's my slope here?
Undefined. Or, well, it's
0 divided by anything is?
It's like it's undefined.
Are we allowed to have 0 in the top?
Yes.
Yes. Yeah, think about it. Negative 2 times what gives me 0? 0. So your slope is going to be 0. Okay, so example 6. What am I going to have in the numerator? 7 minus negative 7, right? Over 6 minus 6. Okay, what's 7 minus negative 7? Those turn to plus, and what do I get? 14. Over 6 minus 6? 0. Am I allowed to have 0 in the denominator? No, so my slope is undefined. Okay? So 0 in the numerator is okay. 0 in the denominator is not allowed. Right? Remember, if you have 0 in the denominator, your graph is vertical and our little man is going to fall off. But if 0 is in the numerator, my graph looks like this. And can our little man walk on that? Yes, he can. Okay? So he won't fall off.